Good day, grade 9s. We're looking at polygon revision, and you can go read through the space and shape document on pages 29 to 44 once again. And then in a polygon with n sides, the sum of its interior angles can be determined by the calculation of substituting n, the number of sides, okay, into the formula 2n minus 4 right angles, which basically just means you times that 2 times the number of sides minus 4 by 90. So many right angles and so many 180 degree angles. In other words, so many triangles is what this formula represents. So it's basically 180 degrees multiplied by your n minus 2, your number of sides, less 2. So if the sides of a convex polygon are produced in order, this is just something you need to remember as well. The sum of the exterior angles so formed is equal to be 4 right angles or a 360 degrees. So then also what it means, if we refer to something as a regular polygon, it means all sides are equal and all angles are equal. So as you can see in our first example over here, this is not a regular polygon. So now determine the value of A is what they tell us to do. And we first need to determine how many sides does our diagram have. And we can count that it has 5 sides and angles. And then therefore it's referred to as a pentagon, just by the way. But what that helps us to do is to determine with the sum of the interior angles formula A. So the sum of the interior angles, as in these angles given to us, okay, and then also using the fact that there are 5 angles. So we say the sum of the interior angles, which is the 3A, 2A, 98 degrees, 102 and 105, so sum of the interior angles, okay, is equal to 180 degrees times n minus 2. And so we substitute the sum of the interior angles will be determined by adding all those angle values given to us. So 3A and 2A, and then 98, 102 and 105 degrees. Okay, so that is equal to 180 degrees times, and now we can replace n with 5 because the n is not the number of, we know the number of sides. That's not what we want to solve. We can replace it, and then what we want to solve is the only variable that's left, and that is a. So 5 sides and angles minus 2, and we can start adding like terms on the left hand side here. 3a plus 2a, those are like terms, and the other like terms would be the sizes of the other angles. So 3a and 2a is 5a, and then 98 and 102 gives you 200, plus 105 gives you 305 degrees. That's equal to 180 times 3, which we know is equal to 540 degrees. Okay, so that remains the same on the left hand side for now. And now I go and isolate our variable by subtracting 305 from each side, and that is leaving 5a isolated on the left hand side equal to 235 degrees. And then lastly, if I divide that by 5a's value or size is equal to 47 degrees. Then they want us to find the sum of the interior angles of a polygon with 23 sides. Okay, so they just want the sum. In other words, we're going to use the sum of the interior angles formula. So sum of interior angles will be determined by the formula 180. It's just the easiest one for me to use. 180 times n minus 2. It's less fuss. So it's 180 times 23 sides minus 2 of those sides. That's how many triangles can be formed inside the polygon. So that is then 21 times 180, which gives you 3,780 degrees. Wow. Okay, so that's the sum of all the interior angles of such a polygon. Number 3, you need to find the number of sides of a polygon when each exterior angle is 30 degrees. So since we know that all of our exterior angles together is 360 degrees, irrelevant of how many sides or angles it has, we can use that. So 360 degrees is the sum of all exterior angles, and whatever number of sides it has, so many sides times 30 degrees will give you the 360 degrees for the sum of the exterior angles. So that's just the setup, but basically if we can rewrite it, it's 30 degrees times n, 30n in a way, and then if we divide by 30 degrees on each side, we isolate n, and then one n is equal to 12. So there are 12 sides. So you can have a look at from G2 question 1.1 till 1.6.